Assalamualaikum and very good day. In this video, I'm going to show you how to get analog inputs and how to manipulate the input that we got to control all the outputs of the NodeMCU. In order to make it easy for you to see the numbering for the connections, I use a simulator on the internet called Tinkercad so that you can see the numbers more clearly. However, the simulator doesn't have the NodeMCU ESP32 in its simulator. For this reason, I use Arduino Uno in the simulator, and I'll use the correct pin numbers on the Arduino Uno that you can compare it with your NodeMCU. As usual, we connect the 3v3 pin using a red colored jumper wire onto the red wire on the breadboard. Next, we are going to connect the ground pin on the NodeMCU with a black jumper wire to the black line on the breadboard. Next, we are going to put an LED onto the breadboard. This LED will act as an indicator for the digital input that we are going to have from the NodeMCU. Connect the ground to the LED's cathode and then connect D2 to the LED's anode. As you can see, we are not going to put any resistor between the NodeMCU and the LED. For this reason, we must make sure that the programming later on should be an analog output, and we should control the value of output to be 100 or less. Next, we are going to construct the circuit for the analog input. For this example, use the photoresistor that you have in your IoT kit. Connect the photoresistor to G5 and G6 on the breadboard. There is no polarity for the photoresistor, so you can put it in any order. Connect the left pin of the photoresistor with the positive line on the breadboard. Connect the other pin to D4 on the NodeMCU. Next, we must make a connection to the ground. However, the connection should be resisted with a 10 kilo ohm resistor. Extend the ground wire so that it will connect to the black line on the other side of the breadboard. Put one pin of the resistor to J6 and the other pin onto the black line on the breadboard. Now spend some time and look at your connections on the breadboard. Make sure that it is the same as shown in this video. As you might have noticed, the circuits are the same as the digital input circuit in the previous video. Once you are satisfied with the connection, now open the Arduino IDE to make some programming for the NodeMCU. We start off by declaring some pins for the LED and for the sensor. Set the LED pin to be number 2 and the sensor pin to number 4. Since we are going to use analog output for this circuit, we must declare some of parameters such as the frequency, the LED channel, and the resolution. We should also set up a variable for the sensor value and set the value as 0. Next, we go to the setup function. As usual, what we need to do is to make the pin mode for all the pins. Set the LED pin as an output and the sensor pin as input. Next, we are going to set up the analog output channel and attach it to the pin. Once finished, we are going to put a serial begin of 9600 in order to make it possible for us to use the serial connection. Serial connection is one of the communication methods to connect the NodeMCU with the computer. Next, we are going to edit the loop function. First, we are going to put the analog read from the sensor pin into the sensor value. Then we are going to use the serial println function to show the sensor value in the serial monitor. Verify your code by clicking on the tick button on the top left of the Arduino IDE. Once finished verifying, upload the sketch onto your NodeMCU. Once the embedded programming is running, click on the serial monitor button on the top right of the Arduino IDE. Set the baud rate to 9600 and see a series of numbers come up on the serial monitor. Now put a finger on top of the photoresistor. Notice that the number on the serial monitor changes when you put the finger on. Record both values that come up from the serial monitor. Now add these two numbers and divide it into 2. As an example, I use the value of 1100 to be the middle value of both of the numbers. Go back to your Arduino IDE and do some more programming. Write an if-else function based on the sensor value. Make the value to be 1100. If the sensor value is less than 1100, it will turn on the LED and also print out it's nighttime on the serial monitor. Continue the if-else function by turning off the LED if its number is more than 1100. Change the serial print ln on the 20th line to serial.print. This is to make the serial output on the serial monitor cleaner and easy to read. Verify your code and then upload it onto your NodeMCU. Turn on the serial monitor and test your connection and programming by putting your finger on top of the LDR to see whether the LED turns on or not. Next, we are going to make another analog input for the NodeMCU. Take out the LDR and the resistor. Reposition the positive wire and the input wire. Before going to the next step, make sure that you turn off the NodeMCU. Take the temperature sensor that is given inside the IoT kit. Make sure that the flat surface is facing you. In this position, the leftmost pin will be the power pin, the middle pin as the output pin, and the rightmost pin is going to be the ground pin. Place the power pin on E5, the output pin on E6, and the ground pin on E7. Use another jumper wire to connect the A7 pin to the ground pin on the breadboard. Make sure all the connections are correct before going to the next phase. Once satisfied, open your Arduino IDE. All the codes from line 1 to line 20 can be used. Add a new variable called temp. Make sure it is declared as float. Make the variable to have an initial value of 0.0. Let's go to the loop function to add some more codes. Code on the line 22 is to change the value from voltage to temperature. Line 23 is used for calibration of the sensor. And line 24 is to adjust the decimal point to be in the correct place. Add another two serial print. One is to show the temperature and the other one to show degrees Celsius. Now verify your code by clicking on the tick button on the top left of the Arduino IDE. Once the verification is complete, upload the code onto your NodeMCU. Once the upload is complete, click on the serial monitor button on top right of the Arduino IDE. It should show a series of numbers that are near to the room temperature, that is 27 degrees. Different people might get different numbers, so we need to calibrate the sensor to make sure that the output is correct. Change the value in line 23. Verify and upload your code. Make sure the output will be 27.0. Do the calibration again until you get 27 in the serial monitor. Once you got 27 in the serial monitor, go back to the Arduino IDE to add some more codes. These following codes are used to control the LED brightness. If the temperature is more than 29, the LED will turn on. The LED will turn off if it is below than 29. Verify your code and then upload it onto your NodeMCU. In a normal condition, the temperature should be 27. In order to increase the temperature of the temperature sensor, you need to pinch the temperature sensor with your thumb and your index finger. Don't pinch it too hard, just leave it long enough so that the temperature of your body will transfer to the temperature sensor. Now you know how to read an analog input and to program it in such a way so that it will affect the output of the NodeMCU. I think that's all. Thank you for watching.